Hi, this is Victor and welcome back to my math tutoring channel. In this video we will talk about the series, and as you know there are many series that you can use to prove if a sum is converging or diverging, and sometimes it gets confusing as of which strategy you should use to prove the convergence. I have a video that teach you on how to choose the right strategy, and the link of that video is in the description of this video below. But first, let's understand this series, and in order to keep my video short and sweet, I will do several short videos explaining these series. In this one, I'll talk about arithmetic series, geometric series, and here I will give you a small example so you understand it well for the geometric series, and two other series, harmonic series and Riemann series. And for the Riemann, I'll do another example. But don't worry, I'll post many examples of series in other video. All what you have to do is look me up. My channel is Vic the Math Tutor. I wrote it in red here, and it is one word. There is no spaces, and you will find many video. There is the entire calculus 2 explanation and some problems, and I will do calculus 1 and linear algebra after. Okay, let's start with the series that I just mentioned before. In general, a series is convergent only if the limit when n goes to infinity of that series is equal to 0. For example, if I have k equal 1 to infinity of ak, so if I do the limit for n goes to infinity of a to an, if this limit is equal to 0, that means it converges. Otherwise, it diverges. So now let's do the arithmetic series. Arithmetic series. Arithmetic series resemble to this one. N equal 1 to infinity of a plus n minus 1 times d, where a and d belong to R. They are real number, and an arithmetic series always diverge. It only converges when a equal to 0, where a and d equal to 0. So a and d equal to 0. So it only converges when a and d is equal to 0. Otherwise, it diverges. The second series we will talk about is the geometric series. A geometric series look like this. Sum n equal 1 to infinity of a times r to the power of n minus 1, where a and r are different than 0, and they are real number, belong to R. Yeah. So a is equal to the first term of that series, first term, R equal the common ratio, and I will tell you about this ratio, and n is the number of terms. A series is a geometric series if the ratio of an plus 1 divided by an is equal to a constant. Is equal to a constant for any n greater than 0. That ratio represents the R that is here. So this is R. Yeah. So this is my ratio that we talked about before. So a geometric series always converges. Geometric, there is an O here. Metric series always converge if, there is an if here, it converges toward a divided by 1 minus r. So as we said, a is the first term and r is the ratio, which is here. If the absolute value of r is less than 1, it converges if the absolute value of r is less than 1. Otherwise, it diverges. Let's do an example here. Let us take that example. Let's take 0.21 periodic, which is equal to 0.21, 21, 21, 21, etc. So this I can write it as 21 divided by 100 plus 21 divided by 100 plus 2 zeros. So 100, I would get those two. If I add 2 zeros, I will add these two plus 21 divided by 6 zeros below, 2, 3, 4, 5, 6, plus etc. So 0.21 periodic is equal the sum of n equal 1 to infinity of 21 multiplied by 10 to the power minus 2, so which is divided by 100 to the power of n. So if n is equal to 1, I will have the first term, and equal to 2, I will have the second term, etc. So this is a geometric series. This is a geometric series because it looks like this one, yeah? So it is a time r to the power n minus 1. And in my case, my a is equal to 21, and my r is equal to the 10 to the power minus 2. So my a equal 21, and my r is equal 1 over 100, or 10 to the power minus 2. Yeah? So we said it converges, it always converges, and we said here it always converges if the absolute value of r is less than 1. So absolute value of 0.01 is less than 1, so it converges. So, and we said it will converge to the term a divided by 1 minus r. And my a is my first term, and my r is my ratio. So it converges toward 21 or 0.21, because here I did a mistake. A is equal to 0.21 because it's my first term. That's my first term. It's not 21, it's 0.21. Let's write it well. 0.21 divided by r divided by 10 to the power minus 2, or 1 over 100, or 0.01. And here there is 1 minus r. So this is equal 0.21 divided by 1 minus 0.01. And 1 minus 0.01 is equal 0.21 divided by 0.99. If I multiply by 100 here and I multiply by 100 there, so it becomes 21 over 99. So this series converges toward, it converges toward 21 over 99. Don't worry, we will do other examples that are a bit more complicated than this one in other videos. So the next series is harmonic series. We said, let's do it here. Harmonic series. A harmonic series look like this: sum of n equal 1 to infinity of 1 over n. And this series always diverge, even if its generic term goes toward 0. So harmonic series is always divergent. and we'll do exercises in other video. Let's talk about Riemann series. The Riemann series look like this: sum n equal 1 to infinity, 1 divided by n, but to the power of p. And the Riemann series, it converge if p is greater than 1, and diverge if p is less. I said greater than 1 and I wrote greater than 0. So if p is greater than 1, and it diverges if p is less. And this can be proven. It converges if p is greater than 1, diverges if p is less than 1. It can be proven by the direct comparison test theorem. We will do an example. You will understand better. So let's start it. Let's take that example. Sum n equal 1 to infinity of 1 divided by square root of 25 n to the power of 3 plus 10. And we want to see if this series diverge or converge. And if it converges toward what? When n goes to infinity, the plus 10 in the square root of 25 and 3 plus 10 is negligible. It does not matter, the plus 10, because infinity plus 10 is infinity. So the 10 is negligible. If I want to study if that series converge or diverge, I can make my life easier and study if this n equal 1 to infinity divided by 1 over square root of 25 n to the power of 3 is diverge or converge. As I said, because infinity plus 10 is always infinity, 10 is negligible. So that series, I can write it n equal 1 to infinity of 1 divided by 5 n to the power 3 divided by 2. So now it looks like a Riemann series, because it is 1 over n to the power of p. And since 3 over 2 is equal 1.5, which is greater than 1, this series converges. So that problem would finish here. But if you want to verify that it really converges, let us compare it with the Riemann series. So if I take 25 n to the power of 3 plus 10, for sure, plus 10, for sure it's greater or equal than 25 n to the power of 3. Yeah, because there is a plus 10 on the left hand side. So if I do the square root of 25 n to the power of 3 plus 10 is greater or equal than the square root of 25 n to the power of 3. And now if I do 1 divided by square root of 25 and 3 plus 10, it becomes less or equal than 1 over 25 and 3 square root. Why? Because 1000 is greater than 100, yeah? But 1 over 1000 is less than 1 over 100. So I just gave you this so you can see it. But I'm sure you know it. So now by the direct comparison test theorem, it's called direct comparison test theorem. Comparison test theorem. That said, if I have two series, sum of n equal 1 to infinity of an, and the other one is sum of n equal 1 to infinity of bn, the n here is below the a. And if 0 less or equal than an, less or equal than Bn. So Bn is greater than An and An is greater than 0. If that series of n equal 1 to infinity of b to the Bn, if it converges, then An converge. So if this converge, that means this converge, and that's we started with this, and then we proved that this converge by that theorem. That means that series here converges. I hope that you like my video. If you like my video, please subscribe to my channel. It is very easy. They won't ask you for your username or password or anything. Just press the button subscribe and that's it. You subscribe. And that would help me a lot. And if you put a like, I would really appreciate it. And as I said, I will post the link for the strategy, which strategy we should take to prove if a series converges or diverges, in the description of this video. Thank you.